Alright guys, so we're out here in the shop again. This time we're in our Toyota Camry right here, the silver one. And basically what I'm going to be doing is an injector power balance test. And we're going to be using our Snap-on Solus Edge right here scan tool to do this power balance test, because this is a functionality test. We need to tell the car to do something that it normally would not want to do. In this case, with our injector power balance test, what we're actually going to be doing is we're turning fuel injectors off and then back on. And what we're doing is we're watching for that RPM difference, that RPM jump that happens when we turn off an injector. It's going to kind of have a little graphy curve, if you can imagine that, of when that injector turns off, the RPM is really going to drop, and then the car is going to try to recover. And then when we turn that injector back on, the opposite is going to happen. The RPM is going to kind of jump, and then the car is going to recover. So I'll show you all that, what that looks like here with our scan tool. You also need a piece of paper to do this, because we're going to be recording our results for our power balance test. We're going to be recording that difference in RPMs with the injector off versus the injector turned on. So again, this will all make sense once I show you guys here. So here's our scan tool. We've got our diagnostic cable hooked up to our scan tool. We're going to hook it up to the car to the diagnostic port, which this car is down here on this corner. And this car is upside down, as I call it. Our data connector is going to be plugged in, basically what I call upside down. And as always, our green light will illuminate. You see there I have glowing green, and our scan tool turns on when we have power. Okay? So now that I've done that, scan tool's on, cable is connected, I can now start the car. Okay? For doing this injector power balance test, you kind of want the car not from a dead cold. You want to have it run for about 5 minutes before you do this, so that the RPMs level out. Because if you start a car from a dead cold, then your RPMs are going to naturally be higher than they would normally be at normal operating temperature, so you're not going to get as accurate of a test. Okay? So what we're going to do is now we're going to start the car here. I have to put the key in because this one beeps the entire time with the key in. There we go. So I did let this car run for about 3 minutes here before, so we're not a complete dead cold right here. But I'm still going to let it run for about another minute before I do this injector power balance test. So what is an injector power balance test going to prove or going to show? Well, what it's going to show is how much power each cylinder contributes to the overall well running of the engine. Okay? So each cylinder, and this is a 4-cylinder car, we'll say this is a 100 horsepower engine, which it makes more than 100 horsepower, but let's just make it a nice round number at 100 horsepower. Well, what is 4 cylinders into 100 horsepower? That means each cylinder should be making about 25 horsepower, or about a quarter or 25% of the power for that engine. So what we're watching and what we're checking is to make sure that each cylinder is producing about what it should. Each cylinder is contributing. Each cylinder's power is balanced. Hence the name power balance test. So this is a good way to do that. Now we can do this by killing the ignition and watching RPM change, or we can do it by killing fuel and watching RPM change. Well, obviously the one that makes more sense is kill the fuel, because if we killed the ignition, we'd be flooding a cylinder, unless we also disabled the fuel. But if we can just disable fuel, bam, easy test, and we do all of that with our scan tool right here. Okay, so you see as the car runs, our temperature's going up and our RPM, our idle, has actually dropped a little bit. So now we can start this test, because this is about where this car is going to idle normally. Okay, so we go into our scanner right here. And this is a Toyota. So again, I can use my thumb over here, or I can touch and scroll. There is Toyota. So I can hit yes, or I can touch it right here. I'm going to try to do the automatic ID, which is the first option right here, automatic ID. We'll see if it works on this car. You see, we're collecting data, we're communicating here. We're just waiting and waiting and waiting. Some cars are faster than others. This one may or may not give us an automatic. Hey, there we go. There's our auto ID. So what we've got is, there's our VIN number. We've got a 2007 Toyota Camry. We are a 2.4 liter L4 or inline 4. Our engine code is 2AZFE right here. So bam, there is our car right here. So I hit OK. That is all correct. So now, same code menu as before. So I can do code scan, or I can go into engine, transmission, anti-lock brakes, airbag, etc., etc. Okay? So what I want is, I want to go back up. I want to go into engine right here, because this is where we're going to find our function tests. So I'm going to select for engine. Now I can go into codes only, clear codes, freeze frame data, data display, check module, actuator tests, reset memory, system tests, generic functions, or troubleshooter. Now, depending on the manufacturer, this output test might be in one of three places for this car. So basically, I'm going to go up to actuator test right here and see if an injector power balance test is one of those that I can do right here. So injector percent is an option. Evap, fuel pump, cooling fans. I can play with my VVTI, fuel cut. Number 1, number 2, number 3, number 4. I could fuel cut all. Or I can do a compression check. I can actually tell this car that I'm doing a compression test. Let's go into fuel cut right here. Okay? Is where we're going to end up. Let me see if this is somewhere else real quick. Okay? I just am curious right here. So I'm going to hit no to get back out. So instead of actuator test, I'm going to go to system test. That's just evap system, so it's not there. Generic functions. Freeze frame data display, onboard, reset. So nope, it's not there either. So now I know that my power balance test for this car is under actuator test. And this is actually where most of them are. But again, it depends on the manufacturer. Okay, so you might have to look around. So again, there's nothing called an injector power balance test on this car. Some cars there is. There's a choice that says injector power balance test. So I'm going to go down to fuel cut number 1 right here, because we're going to start with injector number 1. So what I'm going to do is I'm going to hit yes. Ignition key on, engine running test. Continue. Collecting data. 1 moment, please. Okay. So, my first choice is engine RPM. Okay. What I would like to see is a graph. Okay. How do I get to a graph? Let me go up to engine speed right here, or I touch it. Okay. there's choices up here. You see the 88 above the squiggly line. So if ever I mention the 88 above the squiggly line, this is what I'm talking about right here. This is our graphing function. So if I touch it, PID list, 1 graph, 2 graph, 3 graph. I really only need 1 graph. Here is our engine RPMs. Okay, so you see right now we're at 723-ish RPMs. It's fluctuating a tiny bit, and that's what it is graphing. Okay? There's our range down here. So right now with this car running, our RPM range is between 698 and 738. Okay? That's normal RPM range for this engine right now. Okay? And again, this is in graph form of my little increase in RPM, decrease in RPM, increase in RPM, decrease. Okay? Some cars run smoother than others. This car just has a graph like this. So now what I do is see my fuel cut 1 on or off right here. Okay? I go to my yes. Oops. Sorry, I need to scroll back over to highlight it. You see what I did? Or I could have just touched it. So after I got out of my 88 over squiggly line, I could have just touched fuel cut again. On or off. So now I'm going to select yes. What's going to happen is, and the car is actually shaking right now. RPMs have dropped. Here's our graph. Here's that big RPM drop. You see right now it's starting to stabilize. So this is about where it wants to be. So now I hit yes again, and I hit yes for off. Boom. There's the big spike up when our injector turned back on, and now it should stabilize again. What was our RPM range right here for this test? 544 to 770. 544 to 770 was our RPM. So the lowest it dropped was 544. The highest it spiked was 770. Right now we're back at about 723-ish, which is where we started. But this number right here is important, 544 to 770. So our piece of paper right here, I'm going to write the 770 as our highest minus 544, okay? And we're going to do the math here in a little bit, but basically we're looking for the difference between these two right here, okay? So the difference between 770 and 544, and that's going to be our RPM swing. Okay, so we've got our drop right here. 770 minus 544 equals 226, I believe, is what my calculator said. So we have a 226 RPM difference. Okay, so this is a number to remember. Now we're going to do cylinder 2, the same thing. So I'm going to go out of here. I'm going to touch no. We're going to go out back to the main menu. Now we're going to go down to cylinder 2. We're going to hit yes. Ignition key on, engine running, continue. One moment, please. Now this should automatically take you to this graph. Once you've gone into graphing mode once, it should stay in graphing mode until you get back out of it. How do you get back out of it again? I can come up here and just touch PID list, and it takes me back to this data. But I don't want just the data. I want the graph. So I touch it, touch one graph, and then boom. There I am. So, again, we're down here looking at this. You see right now we're 703 to 733 is just our normal running RPM range. And hey, look, we're about where the other cylinder was. Okay? So what we're going to do is our fuel cut right here. I'm going to select on, and again, we can touch it or we can hit yes. There's our big RPM drop. We're going to let it stabilize. Let it stabilize here for about 5 to 10 seconds. And then I'm going to go in and I'm going to turn it off. And now here's going to be our big RPM spike back up where our injector turned back on. And then it should normalize. What was our swing? 551 to 791. Okay? 551 to 791. So I take my piece of paper for cylinder number 2. 791. 551, and I'll do the math. Now we move on to cylinder number 3. So I hit no to get out of here. Fuel cut number 3. Hit yes. Continue, same thing. There's our happy little graph. There's our current RPM swing. Hit yes. Here's our chug. There's our RPM drop because our injector is off. Again, let it stabilize, 5 to 10 seconds. Here's going to be our RPM jump. Injector's back on, and then we let it stabilize. And here's our swing for this one. 803 to 574. So we're going to write that down. And then we do our last cylinder right here, cylinder number 4. So no to get back out. Scroll down, cylinder number 4. Yes. Continue. Our happy, smooth little graph. Again, our idle range. I'm going to hit yes. And then we turn that injector off. Here's going to be our big drop. Chug, chug, chug right here. Again, wait 5 to 10 seconds for this guy to stabilize. Yes again. Going to select off. Now we'll get our big RPM spike. And then we'll let this guy stabilize. And there's our RPM swing right here. 584 to 806. So I'm going to write that here on my sheet of paper. 806 and 584. And then we need to do the math. Okay, so I've done the math on our RPM drop right here. And as you can see, cylinder number 1, there's a 226 RPM difference. Cylinder number 2 at 240 RPM. Cylinder number 3, 229. Cylinder 4, 222. So cylinders 1, 3, and 4 are within several RPM literally of each other. Cylinder number 2 is at 240. This is a good reading. Okay, 3 cylinders are within just a couple RPM difference of each other, so they're contributing almost identical power. Cylinder number 2 is just slightly higher, so it's making just slightly more power. Is this going to affect anything real world? Probably not. Maybe there's something different about cylinder number 2. The rings are sealing better. There's slightly more carbon in that cylinder, so it's slightly higher compression, making slightly more power. I don't know. But these readings right here indicate this is a good running engine. If you had crazy numbers, if this was like 126 and all of these others looked in the 200s, then you would know cylinder number 1 was not making power like it should. Or if cylinder 2 was like 300 or 400 RPM drop, was making insane amount of power compared to the other 3, then you know the other 3 had a problem. Okay? So that's what this is. This is just kind of a diagnostic of here's about how much power each cylinder is making. Here's how healthy our engine is. It was just like the compression testing that we did. Again, is the engine healthy or is it not? If it's not, here's kind of some stuff you might want to look at. That's really what this injector power balance test is for. Also, this tells us our injectors are really working, because if we had no RPM change by turning on or off an injector on one of these, say one of these was 0 RPM change or very low, 10, 15, 20 RPMs, that would mean that injector itself is bad. So again, this is just a diagnostic. Is your engine healthy? Are your injectors working properly? Awesome. So there's our injector power balance test. Okay? So we can back out of here, and we're back to our main screen. And there we go. Now we can move into different things with this car.